A student built a regular triangular pyramid for a school project. She wants to cover the pyramid with paper. In order to know how much paper to buy, she needs to know the surface area of the pyramid. Find the surface area. So since wrapping paper goes on the outside of the figure, we need to find the surface area of the figure to see how much paper she needs to cover the regular triangular pyramid. Now, since this is a regular triangular pyramid, that means the base is a regular triangle, and that means the base is an equilateral triangle, which means all of the lateral face are going to have the exact same base. So our base has to be a triangle because you identify a figure by its base. Since our base is a triangle, we know it's called a triangular pyramid. Our lateral face must be triangles as well because that's the only way you can get a pyramid. So I'm going to outline my base right here, which is a triangle. So I'm going to draw a neck. So I'm going to draw a regular triangular pyramid. Since it's a regular triangular pyramid, I know that all of my sides and all of my angles are exactly the same. So if this side is 4 centimeters, and this is a regular triangle as a base, I know this side is 4 centimeters, and this side is also 4 centimeters. And now I can find and I need to know what the height is, because you need to know the base and the height to find the area. So if you look right here, I see the base, the triangle and the base is, the height is 3 5/10 centimeters. So the height of my base, and then I need a lateral face to connect to each edge of the base. So I'm going to just, it's a triangular, so I need triangular face. So I'm going to draw a triangle here, a triangle here, and a triangle here. And the height of my triangle, my lateral face, is right here. I can find out where the height, base and the height are perpendicular to each other. So the height of the triangle is going to be 2 9/10 centimeters. So if I look here, I have a base that's the shape of a triangle. So I'm going to use my formula 1/2 times the base times the height, plus the area of my lateral face, which are all the same. So one face plus another lateral face. So we could say this is the left face. We could say this is the right face. And this is the one that's in the back face. And that's the shape of a triangle. So I'm going to need all formulas. All of the formulas to find the area. So I'm going to bring down my plus sign. Now, surface area is the area of the surfaces. So I have to find the area of the bottom surface. Then I need to find the area of the lateral face surfaces, add it all together, and that's going to be surface area, the area of the surfaces. But before I can do that, I need to find my dimensions. So the base have a length of 4 centimeters. If you look right here, it's 4, and the height of the base is 3 5/10. So I'm going to take half of 4. Half of 4 is 2 times 3 5/10. So 3 5/10 times 2 is 7. So I know the area of my base is going to be 7 centimeters squared. Now I need to find the area of my face. And since all of the face have the exact same base of 4 and a height of 2 9/10, they're taking up the same amount of space, which means they're going to have the same area. So I'm going to substitute. My base is 4 and my height is 2 9/10. Once again, I can take half of 4, which is 2, times 2 9/10, and that's going to be my area of the triangle. So the face. So 5 8/10 centimeters squared. Now this figure right here has the exact same dimensions, 1/2 times 2 9/10 times 4. I know I don't have to do the math again. I know it's going to be 5 8/10 because the area of all of the triangles are exactly the same because they take up the same amount of space. So now I can add the area of all of my face, and that'll be the surface area, the area of the surfaces. So I have 5 and 8/10. Now I see that I have three lateral face with the same area, so you can just multiply this by 3. Because remember, addition is repeat, multiplication is repeat addition. So once I do that, I'll end up with 17 and 4/10 centimeters squared. So once I add all of this up, I'll end up with 17 and 4/10 centimeters squared. Then I need to add 7 centimeters to that. You have to align your decimals and place values. So 24 and 4/10 centimeters squared. So that is going to be the surface area, the amount of space, and centimeters squared, the amount of square units that this figure takes up. So remember, area is always two-dimensional because you multiply the length times the width. So that is a two-dimensional quantity. One length is one-dimensional, a straight line is one-dimensional, and volume, which we will talk about in the next one, is three-dimensional. How many cubic units can you fit inside of a figure? So that brings me to this question right here. So volume of a right rectangular prism. So volume is how many cubic units can you fit inside of here. So if I draw a cube, I have a little cube right here, and this cube has an edge length of 1 by 1 by 1. Right? So the volume of this cube is going to be equivalent to length times width times height, which is 1 times 1 times 1, which is equivalent to 1. So the volume of the cube that I'm putting inside of this box is 1. Now you won't always use one edge length cube. Sometimes we have to use fractional edge lengths if we have fractional parts here. So I can put 4 1 by 1 yard edge length cubes across the base, and I can fit 5 1/2 edge length cubes across the length. So the length and the width. So this, I know this is 5 right here because this is 5, so this must be 5 yards, and if this is 5 yards, it's parallel to this part, so this must be 5 yards. So I can fit 5 1-yard cubes across the length and the width. How many can I fit across the height? 3. So 1 2 3. So now I need to see how many cubes I can fit inside of this box. So we can find out how many cubes we can fit across the bottom layer. Volume is equivalent to length times width times height. This is the formula. So we can fit 4 1-yard cubes across the bottom layer, across the length, and we can fit 5 1-yard cubes across the width, and we can fit 3 1-yard cubes across the height. So how many cubes can we fit on the bottom layer? 20. 4 times 5 is 20 yard squared cubes. So since the bottom layer is just length times width, that is how many we can fit on the bottom layer. So if I fill in all of these little lines, then I should be able to fit 20 cubes across the bottom. But I have to go up 3 yards high. So I have 20 in the first layer, then I have 20 in the second layer, and then I have 20 in the third layer. So that's going to be 20 times 3 yards. And that's how I end up with the volume. With 20 times 3 is going to be 60 yards squared. So yards squared is equivalent to yards times yards. And now I need to multiply that by another yard. So that's going to tell me my base yards is a repeat factor 3 times, so it's going to be yards to the third power. So yards to the third power. Volume is three-dimensional because you have a length times a width times a height, and that's how you end up with the volume. So volume is how many cubic units you can fit inside of a figure. How many? So you could literally think of a cube going inside of a rectangular prism or any figure. So we have 60 yards cubed is the volume of this figure. Now you won't always put unit cubes inside of the prism, and you will not just have to do that on your test. So now let's look at this next one. So these are pretty straightforward. If you understand volume, you can easily write the formula, substitute, and evaluate. So my formula to find the volume of a prism will be the area of the base times the height. So volume is equivalent to base times the height. Now this is one formula. So the area of the base is going to be 3 by 5, which is 15, times 2, the area times the height, which is 30. So my base, so B is equivalent to the area of the base. So B is going to be 15. 3 by 5 is 15 yards by 2 yards is the height. So I'm substituting. And then that's how I end up with 30 yards to the third power. Now, this is a higher level formula that you would use, but you can still use volume is equivalent to length times width times height. This length times width is just B. So this is just another way to write the same formula. So length times width, we have a length of 3, a width of 5, and a height of 2. And all of our units of measurements are the same, so we can go ahead and multiply. 3 times 5 is 15 yards squared, times 2 yards squared. Times 2 yards, so I multiplied that and I brought this down. Oops, right here. Now I need to do the last part, which is volume is equivalent to 15 yards squared times 2 yards squared, which is going to be 30 yards squared. So same, two different formulas, same answer. B is equivalent to B, the area of the capital B is equivalent to length times width, or some people say capital B is equivalent to base times height. Either way you look at it, it's the same thing. You get the same answer. If you understand what volume is, you can answer any question about this. And that is all for this lesson.